my bow tie.
All right, now start your intro.
So, good evening. My name is Commandante Sub-Zero, both the temperature and name, and I'd like to invite you into a conversation about the nature of reality. So I'm beginning with my bow tie here, which actually is this. So, what does this look like to you folks?
An hourglass?
Yes, that's exactly it. So, now an hourglass has obviously, this is the past, like an hourglass, the past. So you might think of, at birth, you know, we're born with a lot of potential and possibilities. And then through interacting with some environment, society or culture, these possibilities narrow into some point, which is called the present. Like here we are, here and now, present here and now. And then, you know, from the present point, things can open up again, depending on what you do, because your future is sort of an open place. We don't know exactly what's going to happen. So, and we have here something called the arrow, which is called the arrow of time, going from past to present to future. Now, what I want to get you to think about is about time. Now, when we think about time, we usually think about, right, past, present, and future. And we think of time as a line. It goes from past to present to future. It's like a straight line. So that's the conventional or traditional or sort of normal understanding we have of time. But I want to show you that that normal understanding of time is actually an abstraction. It's not time itself. It's abstraction from time itself. And I want to show you what this abstraction is abstracted from. And to do that, I'm going to show you something. I'm going to show you this. Now, how many sides does this have?
2.
Exactly. But, and I'm sure you're familiar with this, but anyway, you twist it like this, and I'm going to ask, okay, why don't you just put your, okay, how about, Tina? I want you to trace out your finger starting here and go all the way around. There,
Okay.
there, and there, yeah, and there, and there.
Hey,
and
now I'm
there,
upside down.
and there, and there.
I can't keep twisting.
And there, and there, and there, and there, and there. And where do you end up?
Back at the beginning.
Yes. So, how many sides does this figure have?
2.
One side.
Exactly.
Oh.
Right? Because you ended where you began. So you just have one side. Now, what does this have to do with time? You're probably asking. Well, it has to do with this. The Möbius strip is actually a pathway. It's a pathway. You know, path. It's a path. Now, a pathway of what? What makes this path? Well, it turns out that what makes this path is called a quark. Heard of quarks before? Quarks. Quark is a name taken from James Joyce's Finnegan's Wake, called 3 Quarks from Mr. something or another. Anyway, a physicist named Murray Gell-Mann, I believe, took this name from James Joyce, and he assigned it to a fundamental particle of nature. So the quark is very, very small. In fact, it's smaller than an atom. It's subatomic. And what happens, these quarks interact, and they produce the neutrons and protons of a nucleus. And you have nucleus, and then you have an electron, which is another fundamental particle, and you have an atom out of that. Now, why am I talking about all this? Because the quark is a fundamental particle of nature. You can't get anything smaller than a quark. It's fundamental to everything. Everything's made of quarks. We are quarks. We are super quarks, in fact. So when quarks interact, they form atoms. The atoms form molecules. The molecules form cells. And some of these cells are called us. We're made of cells, right? We're made of atoms. Everything's made of atoms. Everything's made of quarks. So we're super quarks. Now, what's interesting about the quark, and this will I'll go back to time, is that a quark has this pathway, and what's interesting is that this pathway has, actually quark has 2 spins to it. 2 spins to it. Now, let's see, Diane? Okay, so, Dan, I want you to take your finger, and you go all the way around like this, and stop here. Now, she stopped halfway. Now, folks, you can see, if we look halfway here, what does it look like? Does it look like this has one side or two sides?
Looks like it has two sides.
Right. But we know, really, how many sides does it have?
One side.
One side. Now, how do we know that it has one side? Well, Tina? Now, this is the halfway point. You pick your finger, go all the way around and around and around, and then where do you come back to? Beginning. In other words, we've made a revolution. We've made a revolution. So in other words, revolution is the movement of fundamental particles of nature. In other words, revolution is the fundamental movement of nature. Everything revolves. Quarks revolve, planets revolve, everything revolves. Now, how about time? Before I go back to time, I want to mention to you that if you took the line that you just formed with your fingers and you took it out and flattened it, you would have this. This is a sine curve, or sine function. Just imagine this being round. If you turn this figure around, you'd have the inside of the Möbius strip. You'd have the Möbius strip. Now, what's interesting is that, now I'm going to talk about time again. This is the first spin of the Möbius strip, and does this remind you of anything you've seen here, for example?
It's a bit like the past.
Exactly. And what does this remind you of?
The future.
Exactly. So in other words, if you put this cone on top of this cone, you would have this. Now, what does it say about time? We usually think that time is straightforward and linear, right? This is the timeline. But actually, if this is actually this, and this belongs to this, and the motion of is the motion of this, is this a straight line that you're making when you go around like this?
No.
No. What motion are you making?
Spin.
Of revolution. So, time is the straight line that we associate with time. The straight linear line of time that we commonly call time is actually an abstraction from the fundamental motion of revolution. That's what I wanted to share with you tonight.
Interesting. Thank you.
And so that would begin the conversation. So if you start getting people thinking about the nature of time, which they usually think about as linear, and you show them that actually time, their linear notion of time is an abstraction from time itself, which is revolutionary in motion, then you might start talking about other things which might be revolutionary. And then you can start talking about other structures and other ideas which they think are fundamental, but may not be so fundamental, which may be abstractions from reality. Because you open their minds up when you say, well, look, linear time is an abstraction from time. Linear time is not time itself.